Hi everyone. Today we will discuss basic properties of electric charge. Previous chapter, previous class, we are discussing about the what is electric charge introduction and what is electric charge, how to produce, how to electrification of the charges accumulated by a body. So by different methods, by friction, by induction, by conduction. Okay, so what are the conductors, insulators, how to define, we are discussing. Today we will discuss basic properties of electric charge and Coulomb's law and multiple charges for the Coulomb's law for the multiple charges. So we know that the electric charge is divided into two types. First one, positive charge. Second one is a negative charge. Okay, so when we are rubbing two bodies to each other, then one body is accumulated negative charge, one another body is accumulated the positive charge. Okay, so for example, a plastic rod is rubbing with cat's fur. So then what happens here? The cat's fur is accumulated negative charge, so it is accumulated positive charge. So positive charge and negative charge, its cat's fur is accumulated, so another charge. Okay, here the size of the body, if the size of the bodies are very small than the distance between them, it's called the point charges. Point charges is nothing but the charges of the bodies, the sizes of the bodies of the charges is smaller than the sizes is smaller than the distance between them, it is called the point charges. Okay, here according to basic properties of electric charge, so here we are discussing addition of additivity of electric charge. So this is the one of the basic property of the electric charge. Okay, so additivity of electric charge. So for example, a system is contains, okay, a system, it contains q1 comma q2 are the two charges. When these are either negative charge or positive charge, both are the positive charges or both are negative charges, or one positive charge another one negative charge, then the total charge of the system equals to q equals to, we have defined that the algebraic sum of these two charges, so it is called the additivity of electric charge. Okay, q equals to q1 plus q2, so either it is positive or negative. So all the sum of the total charge of this system q equals to the algebraic sum of the individual charges. Okay, so for example, we are considering n charges, q1 comma q2 comma q3 comma q4, these are qn. So it contains, a system is contains n charges. So a system is contains n charges, then the total charge, then the total charge of the body, total charge of the system, charge of the system is defined as, so what is total charge equals to q1 plus q2 plus so on plus qn. Okay, this is the total charge of the system q1 plus the algebraic sum of the all charges. Okay, so this is about, so for example, one charge is negative -1, so plus 2 plus 3 plus 4 and -5. So these are 5 charges. So what is the total charge of the system? Total charge of the system, total charge of the system equals to -1 plus 2 plus 3 plus 4 -5. So here -5 minus 1 -6 plus 7. Okay, 2 plus 4 6, 6 plus 3 9, 9 minus 6 equals to plus 3. The charge of the system is equals to plus 3. So this is the addition of the electric charge of the system. And second property is conservation of charge. So charge is conserved. Charge is conserved. So the previous topic we already discussed here. Charge is conserved. Conserved is nothing but no charges. Okay, no new charge is either created or destroyed. Okay, for example, if a body is electrified, okay, if a body is electrified with a different methods, by friction or by induction, by conduction, so any method. So when a body, for example, a glass rod, so we have taken a glass rod, this is glass rod. When a glass rod is electrified, so how to electrify it? So when rubbing with a silk cloth, so the rubbing with a silk cloth continuously, thoroughly, continuously, what happens? It is accumulated negative charge, and silk cloth is it is accumulated positive charge, and silk cloth is accumulated negative charge. So here this glass rod is loss of certain electrons. For example, here 5 electrons is losses. Okay, these 5 electrons losses of a glass rod. Then silk cloth is accumulated negative charge, so the 5 electrons is gained here. So 5 electrons is gained here, 5 electrons is lost. When it is 5 electrons lost, so it is positively charged. Silk cloth 5 electrons is gained, so here it is negatively charged. So it is negatively charged, it is positively charged. So the sum of these electrons -5 plus 5 equals to 0. So then how many electrons are lost of a body with rubbing with another body? So the number of electrons is gained. The total number of electrons is 0. So then according to charge is conservation, no new charge is either created or destroyed. So this is about the conservation of charge. So here for the isolated system, So when a silk cloth is rubbing with a glass rod, so the number of electrons transfer from silk cloth to glass rod or glass rod to silk cloth, so then it is conserved. How many loss of electrons of glass rod? It is gain of electrons of silk cloth. So sometimes the nature is creates charged particles. So for example, we know that so an atom is consist nucleus. Okay, in nucleus it is consist protons and neutrons. So here it is consist electrons. The electrons are revolve around the nucleus continuously. So sometimes the nature is creates charged particle. Charged particles is nothing but so a neutrons turn into protons and electrons. The proton and electron thus created have equal and opposite charges. The total charge is 0. So when neutron is converted into, okay, the neutron is converted into proton and electron. So the proton charge is positive and electron charge is negative. So the number of protons equals to number of electrons, then the total charge is 0. So it is called the charge is conserved or conservation of charge. So next one, quantization of charge. So quantization of charge is nothing but a free charges of the body is integral multiple of the electron charge. So basic unit of charge is denoted by E. So it is experimentally explained R.A. Millikan in 1912. So with his oil drop experiment. So within oil drop experiment, R.A. Millikan is explains that the all free charges are integral multiples of a basic unit of charge denoted by E. So it is called quantization of charge. It is called as quantization of charge. Quantization of charge. Okay. So this quantization of charge is denoted as Q equals to the charge of the body Q equals to plus or minus NE. Okay. Here N is the where N equals to integer. Okay, it is an integer. So E is E equals to, that is electron charge, that is 1.602192 into 10 power of minus 19 coulombs. So this is the charge of the body. So whether it is electron, so we have taken Q equals to minus Ne. Whether it is proton, the Q equals to positive charge, Q equals to plus Ne. Okay, so the charge of the unit charge E equals to 1.602192 into 10 power minus 19 coulombs. Generally we have taken here 1.602 into 10 power of minus 19 coulombs. So this is the basic unit for the a charge. So this equation is explains that the quantization of the body, the charge, the free charge, q equals to plus or minus n into E. Okay, here the fact that electric charge is always an integral multiple of E is determined as quantization of charge. The value of the basic here, then, so for example we have taken here the charge q equals to 1 coulomb. Then how many electrons in a body? So we can calculate with this equation. Q equals to 1 coulomb equals to plus Ne. Here N into E equals to 1.602 into 10 power minus 19. So the number of electrons N equals to 1 by 1.602 into 10 power of minus 19. So number of electrons N equals to, so how much here, 6.6 into, nearly 6 into 10 power of 18 electrons are accumulated on a body. So the number of electrons N equals to 6 into 10 power of 18 electrons. This is about the quantization of charge. Here the Coulomb's law is explains the quantitative statement about the force between 2 point charges. So we are consider 2 point charges, that is negative charges or positive charges. So for example these are positive or negative 2 point charges. These 2 point charges, the distance is small r or capital small d, anyone. So we have taken a positive charge and a positive charge. The force between these 2 point charges are, the force is a repulsive force. When the charges are negative charges, the force between these 2 point charges are also repulsive force. When we are consider a positive charge and a negative charge, so it is taken a distance smaller, so it is consist the force in between them, so it is the force is attractive force. So this force is explained with using a Coulomb's law. According to Coulomb's law, the force between 2 point charges, the force between 2 point charges is directly proportional to product of two charges and inversely proportional to square of the distance between the charges. So this is the Coulomb's law. So for example, let we are consider 2 point charges Q1 and Q2. These are 2 point charges. These 2 point charges, the distance between the 2 point charges we have taken r is the distance between them. the force, attractive force between, when unlike charges, attractive force, when it is like charges, the repulsive force between them. The force is directly proportional to the product of the two charges q1 and q2. The force is inversely proportional to the square of the distance, or F is directly proportional to 1 by r square. From this equation we can combine F is directly proportional to q1 q2 by r square, or a proportional to constant we have taken k into q1 q2 by r square. So this is the force, the attraction force or repulsive force between the two point charges is F equals to k into q1 q2 by r square. So now we are consider these 2 point charges are in a vacuum. So we are taken in a free space or a vacuum. This k equals to 9 into 10 power 9, okay, 9 into 10 power of 9 Newton meter square per coulomb square. So the value of k, so that is k equals to 9 into 10 power of 9 Newton meter square per coulomb square. So when it is a free space, so this k value is denoted as a coulomb. Is experimentally proved that k equals to 1 by 4 pi epsilon naught. So in a free space, so the value is k equals to 1 by 4 pi epsilon naught. Here epsilon naught, this is epsilon naught. Epsilon naught is permittivity in a free space. Okay, so here then we can write here the Coulomb's law, F force F equals to 1 by 4 pi epsilon naught into q1 q2 by r square. Okay, this is the force between two charges. The force, repulsive force or attractive force between two charges F equals to 1 by 4 pi epsilon naught q1 q2 by r square. If the two charges are in any medium, so we have taken any medium, the force F equals to 1 by 4 pi epsilon into q1 q2 by r square. So here epsilon is denotes permittivity of any medium. Permittivity of a medium. Okay, permittivity of a medium. So the relative permittivity, so we have taken the relative permittivity is nothing but the permittivity of a medium divided by permittivity of a free space, that is epsilon by epsilon naught. So from this equation, okay, relative permittivity epsilon r equals to epsilon by epsilon naught, or epsilon equals to epsilon naught into epsilon r. The relation between the epsilon r and epsilon equals to epsilon naught, permittivity in a free space into the relative permittivity. So epsilon equals to epsilon naught into epsilon r. This is about the Coulomb's law. The Coulomb's law is explained that force equals to 1 by 4 pi epsilon into q1 q2 by r square in a medium. The force equals to 1 by 4 pi epsilon naught q1 q2 by r square. This is in a free space. The charge is in a free space. Force equals to 1 by 4 pi epsilon naught q1 q2 by r square. Actually the force is a vector quantity. Then the force Coulomb's equation is written as F equals to 1 by 4 pi epsilon naught in a vector form q1 q2 by r square, or it is written as r12, so it is r12 whole square into r12 cap. So here r12 cap is only a unit charge, it is a unit position, sorry, it is unit position, okay, unit vector, unit position of vector. So for example, these two charges q1 and q2, so this is the origin of the vector, so it is taken as r1, okay, so it is r1 when it is r2, then this resultant position r21 equals to r2 minus r1, okay, r2 minus r1. So then the force between here r1 to the force f12 is nothing but the force of q1 due to q2, the force is f12 equals 1 by 4 pi epsilon naught q1 q2 by r12 square, r12 into r12 cap, okay. Here when we have taken this is in this direction, it is in this direction, the force f21 in this direction, the force is f12 in this direction, so these are opposite direction. So now f21 is nothing but the force of charge q2 due to q1, so then f21 equals to 1 by 4 pi epsilon naught into q1 q2 by r21 square into r21 cap. So this is the force of the charge 2 due to charge q1, charge q2 with respect to charge q1, the force by force f21 equals 1 by 4 pi epsilon naught q1 q2 by r21 square into r21 cap. So the force f12 equals 1 by 4 pi epsilon naught q1 q2 by r12 square into r12 cap. So then the force is opposite here, r21 equals to r2 minus r1, so it equals to minus of r1 minus r2, then r21 equals to minus of r12, okay. Then from this equation, so we can write the force f21 equals to minus of force f12, okay. These are the opposite direction, so it is the forward direction, right side direction, and the f12 is opposite direction, okay. f21 equals to minus of f12. So here the forces between multiple charges, so we are consider multiple charges is nothing but 3 charges or 4 charges, and 3 are above the charges are called the multiple charges. So for example here q1, q2 and q3, these are 3 charges, so this is origin, okay. From this origin the charge, the distance between is r1, this is r2, this is r3, okay. So the distance between q1 and q2 it is r12, the distance between q1 and q3 is r13, okay. the force, the forces between multiple charges. Okay, the force between q1 and q2, so this is F12 equals to, it is written as 1 by 4 pi epsilon naught into q1 q2 by r12 square into r12 cap. Okay, and F13, the force between, okay, the force between, so it is q1 and q3, so the force equals to F13 equals to 1 by 4 pi epsilon naught into q1 q2, so q3 by r13 whole square into r13 cap. So this is equation number 1 and equation number 2. So then the resultant force is taken as F1. So it is taken, so it is the resultant force F1 equals to, okay, F12 plus F13. It is derived from parallelogram law of vectors. So F1 equals to F12 plus F13. So then F1 equals to, here 1 by 4 pi epsilon naught into q1 q2 by r12 square into r12 cap plus 1 by 4 pi epsilon naught into q1 q3 by r13 square into r13 cap. Okay, this is the resultant force at point, this point. The resultant force F1 equals 1 by 4 pi epsilon naught q1 q2 by r12 square into r12 cap plus 1 by 4 pi epsilon naught q1 q3 by r13 square to r13 cap. Okay, so for example we are consider multiple charges, n charges. So what is the resultant force? So for example the n charges is taken as here. So for example this is the origin, okay, it is origin. So here, so for example it is q1 charge, so this is q2 charge, this is q3 charge, and q4, here q4 and q5. So here the direction between here, the direction between here, the direction between here, the direction, so the here, so it is r1, so it is r2, so the distance between q1 and q2, r12, r13, r15, so this is r1, okay, this is r14. So the resultant here, the resultant force, this is the force is F13, this force is F14, so and here the force is F12, here the force is F13, so F15. So then the resultant force F1, so here we can find out F1 equals to, so it is taken from the parallelogram law. So then F1 equals to F12 plus F13 plus so on F1n. Okay, this is the resultant force of the multiple charges. So then it is written as F1 equals to So q1 is common by 4 pi epsilon naught into summation of sigma of qi by r1i square into r1i cap. So here I equals to 2 to n. So this is the force at this point. The force F1 equals to Q1 by 4 pi epsilon naught sigma I equals to 2 to n Qi by R1i square into R1i cap. So the vector sum is obtained as used by the parallelogram of addition of vectors. So this is the resultant vector. So from Q1 to this all resultant of forces. So F1 equals to F12 plus F13 plus so on F1n. This is about the forces between the multiple charges. Next class we will discuss the electric field and electric field lines. Thank you.